Yes,
Okay.
ma'am.
So yes, can we start with a further part?
Yes, ma'am.
Fine. Quickly, can you tell me the formula for barium chloride? Chemical formula for barium chloride.
BaCl.
BA.
Cl.
Okay, let's check. Okay. Barium, chlorine. Okay. So barium is
Yes, ma'am.
+2. Okay. Chlorine
Oh,
is -1. What will we get?
BaCl2.
Hmm. Okay, that means barium needs to lose 2 electrons. Okay. And if
Yes, ma'am.
chlorine is reacting with barium, then obviously we will be needing 2 chlorine atoms to actually suffice for that 2 + 2 valency, yes or no? If 2 chlorine atoms will be there, then only we'll be able to gain those 2 electrons, 1 atom each.
Can you
No.
repeat one
Yes,
last
I
time?
repeat. Listen, see. But how many in this? How many? This is one molecule, yes, of barium
Yes,
chloride.
ma'am.
How many barium atoms?
2. I mean 1.
Barium,
Atom 1.
one. Okay, this is barium. How many chlorine atoms?
2.
2. This is 1. This is 1. Is it okay?
Yes.
Now see, barium has a valency of +2. Can we infer from this that it will be losing the 2 electrons?
Yes, ma'am.
So it is losing these 2 electrons. Okay. Now, one chlorine atom has a valency of -1. That means
Yes,
one
ma'am.
chlorine atom can gain 1 electron.
Yes, ma'am.
So if one barium atom loses 2 electrons, how many atoms of chlorine will we need, given that each atom can only have 1 electron? See,
One
one will be gained by
one
this,
electron
one will
per
be gained by
chlorine.
this. Yes.
Yeah, one for
So,
each.
yes. So therefore, we will be needing 2 chlorine atoms for one barium atom. Yes or no?
Yes, ma'am.
Are you able to imagine it physically? Yes or no? Properly?
Yes, ma'am.
How do we get
Yes,
this
ma'am.
formula of BaCl2?
Yes, ma'am.
Is it clear, beta?
Ma'am, but then why is it only one for each?
One for each, because remember that the valency of chlorine is -1. It can only gain 1 electron.
Okay.
Are you
Okay.
able to understand that? Yes. You know, we
Yes,
cannot
ma'am.
give more electrons than the capacity. We have to also look at the capacity. It can only have one
Yes.
electron. It already has 17 electrons. It already has 7 electrons in the third shell. It clearly just wants to gain 1 so that it fills the third shell. Yes.
Yes, ma'am.
Are you able to understand it now?
Yes.
Clear 100%?
Yes, ma'am.
Fine. Now, coming on to the next part, beta. So when we have understood the chemical change, we have understood the chemical reaction. What is a chemical reaction? I have already discussed this with you. Any change in the chemical configuration will lead to the chemical change. And
Yes.
that is what a chemical reaction is. When different
Yes.
reactants are going through the chemical change to actually form a new product or a new substance, which is chemically different from the reactants. Yes or no?
Yes, ma'am.
So can I say that chemical reaction beta involves reactants, okay, which
Yes, ma'am.
will undergo some change in their chemical configuration to form new products or new substances which are referred to as products. Yes or no?
Can we repeat one?
Yes. I'm saying in a chemical reaction, we have
Yes,
initially
ma'am.
some substances which are called as reactants, because
Yes, ma'am.
these reactants undergo the change in their chemical configuration. And if there is a
Yes,
change
ma'am.
in their chemical configuration, clearly a new product is there,
Yes, ma'am.
and though a new substance is there, and those new substances are referred to as products of the reaction. Is it
Yes.
clear? 100%?
Yes. Yes,
Now
ma'am.
see, a chemical reaction, a chemical reaction is actually represented by a chemical equation. Is represented by a chemical
Chemical equation.
equation. It is nothing but, again, we have the reactants, we have the products, we have the conditions of the reactions, and that's it. That is a chemical equation. Okay.
Yes, ma'am.
We are equating something. What are we equating? We are equating reactants to the product.
Yes, ma'am.
Okay. So just give me
Yes,
a
ma'am.
second. Yes. Okay. So that is how we know about chemical equation. Now, but some quick points about chemical equation. Generally, in a chemical equation, reactants are on the left hand side. Okay. Left hand side.
Yes, ma'am.
The products are on the
Right answer.
Right hand side. Okay. There is an arrow in between that represents the direction of the chemical change. Direction of the
Yes.
chemical change means, see, reactants are changing to the products. Yes.
Yes, ma'am.
So the reaction is proceeding from the reactants towards the products. Yes or no?
Yes, ma'am.
Clearly, if this means the direction is from the reactants to the products, that means the number of reactants, the quantity of the reactants will decrease, and that will be changing to the products. So definitely the quantity of the products will increase. Yes or no?
Yes, ma'am.
Do you agree with that? Do you understand that?
Yes, ma'am.
Okay. The next point is that we have some of the conditions. Example, let's say a particular temperature at which the temperature at which the reaction takes place, some particular catalysts that have been utilized. All of that are written here on the
Top of the
arrow.
Yeah.
Okay. Top or below of the arrow, on the arrow. Okay. That's it.
Yes.
And we can have more than 2, more than 3 reactors, more than 1 reactant. We can have more than 1 product. If we have, let's say, 3 reactants, how will we display them? We will simply, let's say we have A, B, and C as the reactants. We'll just write a plus sign between them and we'll denote them as
Yes.
reactants. And if we have, let's say, E, F, G, these are the products. Okay.
Yes,
Now,
ma'am.
one more important point. If, let's say, in the product, there's some gas which is being released as a result of the reaction, okay, we will always show a arrow like this. This means
Yes,
the
ma'am.
gas is being released. Is it okay? Let's say
Yes,
there's
ma'am.
a reaction in which hydrogen gas is released. Okay. So we'll actually show this arrow by the hydrogen. Okay.
Yes, ma'am.
Fine. See, one very important point. In all the reactants and the products, it is very important to mention the state of the reactants and the products. The state can be solid,
Yes.
liquid, gaseous,
Liquid.
or aqueous. What do we mean by aqueous?
It's a solution.
Yeah, it's a solution when the solvent is water. Okay.
Yes.
When the solvent is water, that is the aqueous form. Okay. Wonderful.
Yes.
So always write them in the subscript. Subscript you understand like this. That's it.
Yeah.
Yeah. That is the subscript. Is that clear?
Yes, ma'am.
Any other problem in here?
No, no.
Fine. Coming on to the next part, that is chemical equations, learning about chemical equations. See, if I say, beta, we are obviously discussing chemical equations, right? So if I say magnesium is one reactant and oxygen is another reactant, so obviously I will write it like this because there are 2 reactants, so I'll have a plus sign in between. Okay, they would be going some change with, okay, in their chemical configuration and they'll be forming a product. Now, clearly, if I write the product, we know it's magnesium oxide. I'll discuss how do we know this, but it's magnesium oxide, okay? Now, clearly, the magnesium, the oxygen, the magnesium oxide, these are all very big, terms. Therefore, to have a very convenient use of the equations, we use chemical formula or the chemical symbol, okay? Chemical formula or the chemical symbol for the respective reactants and the products. Symbols will definitely be for the elements. Example, magnesium represented by Mg. This is a symbol for magnesium. O represented by O2. This is a symbol for oxygen. Okay. And
Yes.
this magnesium oxide, this is a chemical formula. I hope it is clear
Yes.
because it is a compound.
Yeah.
So I hope
Yes,
you know
ma'am.
the difference between the symbol and the formula. Okay.
Yes, ma'am.
And yesterday we have discussed in detail how do we know the formulas. Okay. How do we get to know the chemical formulas. Okay. Fine. Clear?
Yes.
Moving on to the next point. See what happens. Now, if I ask you one thing, if we have written it like this, beta, this clearly becomes a chemical equation
Yes, ma'am.
with magnesium and oxygen as the reactants and magnesium oxide as the
Product.
product. So this is the simplest form, gaseous,
Yes,
solid,
ma'am.
solid. Okay, that's fine. Now, if I
Yes.
ask you, beta, let's just do one thing. Okay, let's just do
Ma'am,
one thing.
I had a
Yes.
doubt in this. How do you know which state of matter they're in?
See, that is generally the known part, right? Oxygen we know is in the gaseous state. Yes.
Yes, ma'am.
Magnesium, we are actually assuming that we have a magnesium ribbon. So that is obviously solid, yes.
Okay.
And when the product is formed, it is formed in the salt form. So that is obviously solid.
Okay.
Okay.
What
Is
about
it clear?
other chemical equations, ma'am?
We will get to know as we come on to them. Okay. We'll discuss that. No worry.
Yes.
Okay. See, look here. If I ask you, beta, in this chemical equation, that is Mg plus O2 gives you MgO. Okay. How many magnesium atoms do we have in the reactant side, beta?
-2.
Mm-hmm.
+2.
Magnesium atoms, number of magnesium
Atoms is
atoms.
1.
one atom. Yes. Is it clear? How many
Yes, ma'am.
oxygen atoms, beta?
One. Oh, two. Sorry.
Kezia, I don't expect these silly mistakes again and again.
Yes, sir.
Wait. Two oxygen atoms, but clearly one oxygen molecule. Okay.
Yes, ma'am.
Right? So I hope the concept is clear. This was just a silly mistake in the last time. How many
Yes.
atoms in this magnesium oxide? This is a compound. How many atoms in this total?
Ma'am, you're getting stuck.
Hello. Is it fine
You're
now?
getting stuck.
Is it okay now? Refresh it. Refresh it.
Yes, ma'am, it's fine.
Fine. I'm asking in the magnesium oxide, that is a compound.
Yes, ma'am.
Yes. Clearly,
Yes,
if it's
ma'am.
a compound, it's a molecule, right?
Yes, ma'am.
How many total atoms does magnesium oxide have?
Two, ma'am. Three, two.
Two. And
Two.
two. And what are those atoms?
One magnesium and one oxygen.
Wonderful. So in total, beta, it has two atoms, one magnesium and one oxygen, right? Please pay attention now.
Yes, ma'am.
See, this is a chemical equation that represents the chemical reaction taking place. But are you sure? Let's see one thing. I'll give you one example here. Pay attention to this. Then I'll come back to this example. Okay. If I say you bought what? Four t-shirts for yourself. Okay. An example. And at home, don't you think you should obviously have four t-shirts when you come to home? If you have
Yes,
three
ma'am.
t-shirts, obviously there's something wrong.
Yes, ma'am.
So the number of t-shirts that you took should be actually the number of t-shirts that you actually got home,
Yes, ma'am.
right? Something has to be balanced here. Yes or no?
Yes, ma'am.
Yes. So please apply the same logic here. When
So it'll
one
be
magnesium,
Mg2, ma'am.
when one magnesium atom is reacting, one is here in the product also. Yes. So magnesium
Yes,
is
ma'am.
same in the reactant and the product. But when two
Yes.
oxygen atoms are reacting here in the reactant, okay, clearly in the product side also there should be two oxygen atoms. Their bonding
Yes.
could be changed, but the atoms should remain same. Yes or no? The number of atoms.
Yes. Yes,
So
ma'am.
clearly it is not balanced. See, any chemical equation that simply represents the chemical reaction taking place is referred to as a skeleton chemical equation. Okay.
Yes, ma'am. Yes,
Are
ma'am.
you able to understand this? Now we
Yes,
have
ma'am.
a law which says law of conservation of mass.
Yes,
Law
ma'am.
of,
Conservation of mass.
and we need to balance the chemical equations based on this law. Okay. Why? What does this say? See, if we had one magnesium atom, let's say the mass of one magnesium atom is X. Okay. The mass of one oxygen atom is Y. So in the reactant side, we have total mass what? X and Y, because one magnesium
Yes,
atom.
ma'am.
And how many oxygen atoms in the reactant side? O2.
One.
Mm-hmm.
No, in
O2.
the reactant side, it's one, right?
Yeah.
Oh, in the reactant side, it's two. Product side is one.
Yes. Yeah. Beta.
Yes.
Fine.
Yes, ma'am.
So what will be
Yes.
the total mass? It will be X plus 2Y,
Yes, ma'am.
right? This is the mass on the reactant side. Okay.
Yes, ma'am.
Now on the product side, what is the mass? X plus Y, yes
X
or no?
plus Y. Yes,
So
ma'am.
clearly it's not balanced. The mass has to be balanced, yes or no? So for the
Yes.
masses to be balanced, for the law of conservation of mass to be applied and followed, we need to balance the chemical equation, and that is referred to as the balanced chemical equation. Is it clear?
Yes, ma'am.
So what do I do if I calculate the number of atoms on the reactant side and on the product side of each reactant taking place? I'll be able to balance the mass, yes or no?
Yes,
So
ma'am.
please understand this. This is how to balance a chemical equation. This is very important. Do you have your notebook by your side?
Yes, ma'am.
Are you writing it? Okay. Now see how to balance the chemical. See, KJ, there are 4 steps that I'll be telling you. It's not mentioned in any book or NCRT, but if you follow these steps, it becomes really easy to balance the chemical equations. Okay.
Yes, ma'am.
So what are those steps? See, first step, please try to understand better. Okay. First step is, in the chemical reaction, we'll obviously be having the reactants and the products. Okay. So
Yes, sir.
first balance any metal, obviously in the reactants and the product side. Let's say, beta, we had A, B, C, D, E as 5 reactants. Okay. We'll
Yes,
obviously
ma'am.
be forming A, B, 2, C, 3, E, D, 4, F. Let's say, okay, this is some of our product based on the reactant. Just assume, okay.
Yes.
And out of those, I say A and C are the metals. Okay. A and C are
Yes,
the
ma'am.
metals. So
Metal.
what we'll do is that first we will balance either of them. Let's say we take A first. We balance the number of atoms here in the reactant side of A and then also on the product side. Okay. So we balance the number of atoms of A only on the reactants and the product side. Is it clear?
Yes, ma'am.
And then because C is also a metal, we'll also follow the same procedure for C. Is it clear?
Yes,
Now
ma'am.
coming on to the next point, beta, we have then balance any non-metal. Balance any. I hope you are clear with the metals and the non-metals, beta.
No, ma'am.
I'll give you the examples. No worry. Balance any
Ma'am, you
non-metals.
said the balance is any
Yes, yes.
elements.
Minus the elements that generally have a minus charge overall. That means they tend to gain the electrons are referred to as non-metals. And those elements which tend to lose the electrons are referred to as metals. Yes,
So those with positive valencies are
yes,
metals.
metals. Yes, exactly. Wonderful. So here, balance any non-metals in the chemical equation on the reactants and the product side both. Okay. See, beta,
Yes.
oxygen is also a non-metal. Okay. Oxygen is also a non-metal. But while you are following these steps, just to make it very convenient for you, balance any non-metal in the chemical equation except oxygen and hydrogen. That's except oxygen and hydrogen, because for oxygen and hydrogen we have separate steps. Then the third part is to balance the oxygen atom. Fourth is to balance the hydrogen atom. Clear?
Oh, yes, ma'am. 1 second.
Yeah. I'm writing down the examples, the most commonly used examples of metals and non-metals. Please pay attention. Metals, beta. Sodium, potassium, calcium, magnesium, aluminium, copper, iron, zinc, beryllium, barium. Okay. So these are the most commonly used examples of metals.
Sure.
Silver, lead,
And what's after iron?
what?
What's after
Zinc,
iron?
Zn, zinc.
N. Ma'am, Be is beryllium.
Be, yes, it is beryllium. Ba is barium. Okay.
Oh, okay. Yes. Yes, ma'am. Done.
Then quickly some non-metals, beta. Most commonly used non-metals. Oxygen, chlorine, bromine, iodine, fluorine. Okay.
Phosphorus, sulfur,
Sulfur,
chlorine,
phosphorus. Yes, very good. Nitrogen, carbon. Okay.
oxygen, fluorine. Hydrogen.
Hydrogen actually can be considered both as a metal and a non-metal, but okay, just don't write it here because you in the steps to balance the equation, we have the last step for hydrogen only, so don't write it here. Okay, is it clear, beta?
Oh, yes, ma'am. Ma'am, can you scroll down writing
Oh
that?
yes.
Ma'am, what is I again?
I is iodine.
Okay. And F is
Fluorine.
Oh.
Yes.
And what's S and P?
S is sulfur, P is phosphorus.
N is nitrogen, C is carbon.
Yes, C is carbon.
Done.
Done? Okay.
Yes.
Now see. We'll take with the simplest of the examples, okay? So example, the first example. I will try to discuss this one only. First, for this, beta, you should know how to calculate the or how to make the chemical formulae. Then only you will be able to balance it. If I tell you magnesium and oxygen are the reactants, you will be able to know the product. Okay, you should be able to know the product. That is magnesium oxide here. Okay.
Yes.
Then only you will be able to balance it. So now quickly balance it. What is the metal here? First step, metal. Yes.
Magnesium is metal.
Magnesium is metal. How many magnesium atoms here?
1.
And how many in the product?
1.
So that is balanced. Yes.
Yes.
Now the non-metal, we don't have any non-metal here.
Yes, sir.
Third, oxygen. Yes. How
Yes,
many
sir.
oxygen atoms here?
2.
2. How many here?
1.
Clearly not balanced. Yes.
Yes, sir.
So what we'll do is that we'll add a 2 here. Okay. Now see if oxygen is
Yes, sir.
balanced. Yes, it is balanced. But again,
Yes.
go back to the first step. If magnesium is balanced here or not? No, it's not balanced. Yes. Because now here magnesium becomes 2. Yes or
Yes,
no?
sir.
And here
Yes,
it's
sir.
only 1. So we also need to
Yes, sir.
balance magnesium here. Is this balanced? Let's see. 2 magnesium atoms on the reactant side, 2 magnesium atoms on the product side, 2
Yes,
oxygen
sir.
atoms on the reactant side, 2 oxygen atoms on the product side. Clearly, it's a balanced equation.
Yes, ma'am.
Is it clear, beta?
Yes, ma'am.
Fine. Coming on to the next part.
Yes, ma'am.
Hmm.
Ma'am, is it 2HU?
Yeah, but tell me, how do we get to know that? See, follow
There
from the
is
beginning.
one.
Is there any metal here?
In the reactant side.
In the chemical reaction, beta, yeah.
Chlorine. No, chlorine. No, ma'am. No metals.
No metal. Any non-metal?
Yes, chlorine.
What is that? Chlorine. Okay. So now see, let's try to balance chlorine first. How many atoms on the reactant side? 1.
2, ma'am. 4 reactant.
Reactant on
1,
the
ma'am.
product side? 2.
2.
Okay. Clearly not balanced. So we'll try to balance chlorine first. We'll add a 2 here.
Yes, ma'am.
Now see, now refer to this equation. Okay. Now any oxygen here?
Oxygen. No.
Any hydrogen here?
Yes.
How many hydrogens here?
2. Oh,
2. How many
yeah,
here?
2. 2.
2. Balanced. Clear?
Yes, ma'am. Ma'am, about
Mm-hmm.
the metals and non-metals,
Mm-hmm.
how do I, as soon as you ask them, I don't know how to.
By practice.
Oh,
Clear, beta? I'm giving a example. Please try to solve it. Okay.
yes, ma'am.
Tell me, if iron is reacted with water, I'm telling you the what will be the reactant, and you will tell me the formula. Okay.
Yes, ma'am.
So if iron is reacted with water, ferric oxide will be formed. Ferric oxide and
Yes, ma'am.
hydrogen gas. Tell me the formulas, beta.
Means, first we have to do the hydrogen, then oxygen, right?
Just
Or
wait a
oxygen.
second. Just. Yes, Kezia.
1 second.
Present, Kezia.
Yes, ma'am. Is it
Yes.
Fe plus 2H2O gives FeO2 plus 2H2 as gas?
Tell me the chemical formula for ferric oxide, that's it, and hydrogen. These are two
Oh,
products that are formed. You just have to tell me the chemical formula. I don't know what are you telling me. I don't even think so that is a balanced equation. Okay. So how did you balance the equation without getting to know the products?
ma'am, ferric oxide plus hydrogen,
What is ferric oxide? Chemical formula?
FeO2.
Mm-hmm.
Oh, ferric.
Listen, ferric, remember. Fe, if ferric, that means Fe will be having a,
3.
yes, plus 3. Oxide,
I
obviously
forgot
oxygen, minus 2. What is it? Fe,
Fe2O3. 2O3.
okay. This is what?
Yes.
Ferric oxide, okay.
Yes.
Now this is ferric oxide. What is hydrogen?
H2.
H2. Now these are the products, okay. Now balance the equation and follow the steps in balancing the equation that we have just discussed. Try to balance it and then we'll discuss, okay.
Yes, ma'am. Ma'am, okay. Yeah.
Mm-hmm.
No,
Done.
no, no. No, ma'am, 1 second.
Okay. I hope, Kezia, you have started enjoying chemistry.
Yes, ma'am.
Okay.
Ma'am, shall I say?
Yes, please say that.
2Fe
2Fe. Mm-hmm. Let me just write it. Just a second. Mm-hmm.
plus 3H2O
Plus 3 H2O. Okay.
gives Fe2O3 plus 3H2.
Fine. Done.
Yes, ma'am.
Okay. Now quickly tell me what did you do in order to get this equation as the balanced one?
Ma'am, first balance the metal ferrous,
And
iron,
what is the metal here?
iron.
Iron. And then what did you do?
Added 2 on the reactant side.
Okay. See, I'll start from the beginning. Better. Okay. This is it. First, we have to balance the metal according to you. That is iron, right?
Yes, yes,
So
ma'am.
in the reactant side, how many ions are there?
2. Oh, on the product
Beta,
side 2. On the reactant side 1.
1. What has happened to you, beta? Mathematics has gone for a toss,
No,
huh?
ma'am, I was seeing the second line. I forgot the first one.
Okay, okay. No, that is the balance. I'm asking in the unbalanced equation, okay?
Yes,
In the unbalanced equation, we have how many iron atoms? 1.
1,
On the product side,
2.
2. So do we need to balance it?
Yes, ma'am.
So you say 2Fe, yes?
Yes, ma'am.
Okay, fine. So this is the equation that we get after that, right? Now
Yes,
we'll have
ma'am.
to look into it. After metal, if our
Yes.
metal is balanced, what do we need to do?
Non-metal, but there's no non-metal.
No, non-metal, very good. The third step,
Uh, Ma'am, but oxygen we won't consider it, right? Because
No,
it's there.
we'll consider it separately. Yes, wonderful.
Yes, ma'am.
So
Third,
oxygen
we
now.
will consider oxygen use.
Okay, how many oxygen atoms in the reaction side, beta? In this equation that you have balanced right now for iron?
1.
1. Okay. In the product side, beta?
3.
The balanced.
No, no.
So what do I do?
I add 3 to the reactant side in H2.
Fine. Now you say it is a fine. Now see if we have balanced this oxygen, is our iron balanced because of this balancing of the equation? Yes or no? I think it is. Yes.
Yes, ma'am.
Fine. Now hydrogen.
Hydrogen is not balanced because there's a
So
3 on that side.
how many hydrogens here? Beta, then consider this equation only. Okay. How many hydrogens
Yes,
here?
6.
Very good. How many here?
2.
2. What do we do?
Add 3.
2. 2 what beta?
2 H2, ma'am.
2 H2. Here.
No, 3 added to H2.
This.
Yes, ma'am.
Yes. Let's just look at it for a second. Okay. Is it
Yes,
balanced?
ma'am.
You will tell me is it balanced?
Yes, ma'am. It is balanced.
And do you think there's any mistake?
What, ma'am?
Do you think there's any mistake in this?
No, no,
Mm,
ma'am.
no. Okay, fine. Good. Now if I say beta, one more product, write it for one more equation, similar, very similar, okay? Then we'll
Yes,
try to
ma'am.
understand the difference here, okay? That is, by the way, let me just tell you it's correctly done, okay? Good, well done. The next we have, again, we have iron plus H2O. That will give you Fe3O4, okay, plus H2. Let's assume the product have already been given to you. Now try to balance it. And now tell me the product. Now tell me the balanced equation.
Done.
Yes, Kezia.
Yes, ma'am.
Tell me.
3 Fe,
3E, 3Fe.
3 Fe,
Okay.
plus 4 H2O
Mm-hmm.
gives Fe3O4
Mm-hmm.
plus 4 H2.
4H2.
Yes, ma'am.
Let's try to understand it. Okay.
Yes,
Let's
ma'am.
try to find out whether correctly balanced or not. So first one, what do we need to do?
Balance the iron
Iron.
as it's a
Beta,
metal.
it's iron. That's iron. Okay. There's a difference between iron and iron. Okay. So
Okay.
when we say iron, that is a charged atom.
Okay.
Okay. Just don't get confused in that. Okay. So this is iron here. How many iron atoms here?
1,
How many here beta on the product side?
3.
3. So what do? We add a 3 to Fe. Yes.
Yes, ma'am.
So we get something like this. Now from this equation, okay, we'll have to check. So 3Fe plus H2O. What do we need to balance now? Oxygen.
Oxygen
How many
as
oxygen
a
atoms here? Yeah,
1,
one oxygen. How many here beta?
4.
4 oxygen atoms. Balanced or not?
No, not balanced.
So what do I do?
3 Fe plus 4 H2.
1. Now, so oxygen. Let's first check for iron again. Is it balanced because of the balancing of oxygen?
Yes.
Fine.
Yes.
Then what is left? Now go through this equation. So how many hydrogen atoms here beta?
8.
8. How many here?
2.
What do we do?
4. We add 4 to the.
Is it clear? I hope the points are clear.
Yes.
Fine. Any problem here?
No.
Fine. Should I give you one more example?
Sure.
That was not a very happy sure, but fine. What happened?
No, I didn't hear you. I didn't hear you.
Okay, no worries. Okay, this is an equation. Please try to balance it. Okay.
Ma'am, is it ammonia?
This, you tell me,
No.
NH3 is what?
NH3 is NH4 is ammonia.
It is, see, NH3 is ammonia. NH4 plus is
Ammonia.
ammonium ion. Okay.
Okay. Ma'am, the ammonium is NH4 minus.
NH4 plus 1.
A plus one. Yeah, correct.
Okay.
Ammonia is NH3.
Yes, ammonia is NH3. That's it.
No,
0 charge on it.
minus.
Beta, it's a
Oh,
product. I mean, it's a compound with 0 charge. Okay, it's not an ionic compound. Ammonium is an ionic compound. Okay.
okay. Done, ma'am.
Very good. Let me know what's your final balanced equation.
Oh, yes. 3CuO plus 2NH3 gives 3Cu plus N2 plus 3H2O.
Okay, let's quickly try to analyze it. Okay.
Yes, ma'am.
So this, how many copper? What is the metal here in that equation?
Copper.
Copper. And what's the non-metal?
Nitrogen.
Very good. What's the oxygen? We have oxygen and hydrogen separately.
Hydrogen.
Okay. Wonderful. So the first one, beta, metal. Yes, copper.
Yes, ma'am.
How many copper here? Atoms here?
It's balanced. It's 1.
1. So we don't need to do anything to copper. Fine. Second,
Yes,
we
ma'am.
need to move on to the nitrogen.
Yes, ma'am.
How many nitrogens here in the reactant side, beta?
1.
How many here on the product side?
2.
What do? We added 2NH3, yes?
NH3. Yes, ma'am.
Is this making any difference to the copper balance? Yes or no?
No, ma'am.
So we can just write it as CuO plus 2NH3. Very good. That gives you Cu plus N2 plus H2O. Very good.
H2O.
Coming on to oxygen, beta. How many oxygen atoms here?
1.
1. How many here?